Good morning. I'm going to go over the solutions. This is the Algebra Thanksgiving packet test. And this is the second page. This is page 2, which is all about exponents, laws of exponents. The retake for this will be on Monday, which is why I'm going over this first. For the first 8 problems, version 1 and A and B are the same, so I'm gonna do them at the same time. Version A and B are here the same for the first few problems. If you want just the answers, that is on a picture that I took and uploaded and posted to your December folder. Okay, so number 9 asks you to simplify. In fact, everything on this page is to simplify. That means just use whatever order of operations to just rearrange and restate in a more simple form this problem. My first thing is to put equal signs to establish my railroad tracks. Big picture, what do I see on a big picture level? I see that something is being multiplied to something else, which is being cubed. Okay, so big picture, I see something times something cubed. If I zoom out, that's what I see. Well, then I'm just gonna first do my cube. Okay, even the parentheses is first. There's nothing much I could do inside the parentheses. So my next thing, according to PEMDAS, I can't do any parentheses here because nothing is simplifiable. Nothing is simplifiable, so my exponent will be next. I know from my exponent rule that I could distribute these exponents because the reason being, let's just make this my notes over here. Give me a second. Reason being, if I cube this, 2y cubed, that's really 2y times 2y times 2y, which I could rearrange to 2 times 2 times 2 times y times y times y. So it's really 2 cubed y cubed. So do you see that's why? Don't just memorize rules without understanding them. If you don't remember the rule, go back to what does it mean to cube something. It means to multiply it by itself 3 times. Well, then I know that I'm allowed to say that is 2 cubed times y cubed because of what I just tested out over here. Well, 2 cubed, I'm going to keep everything. Don't lose anything that you're not touching yet. 2 cubed is 8, y cubed is 3. Now, these parentheses, again, I was explaining in tutoring yesterday, if you're among friends, look, they're on the same level. They're all being multiply. If you're just among multiplying friends, then you don't need those parentheses. There's no need to have dividers up. We're all just multiplying here. So let's just multiply. And the order doesn't matter. So 8 times 4 is 32. X times no other x is just x there. There's y squared and y cubed. Now, can I multiply these exponents or add them? I don't remember. Is that 2 plus 3 is 5? Or 2 times 3 is 6? What goes here? Well, if you don't remember, go back to the basics. What does y squared mean? Y squared means y times y. What does y cubed mean? It means y times y times y. And when you're multiplying, we just say, oh, how many y's do I have? Y. I have 5 y's. So you're right. Oh, it was an adding rule. Okay, so there's my answer. If you don't watch this whole video, you can, if you'd like, just on YouTube that you need. Okay? Give me 1 second while I return this call. So you guys know that when you're... Hi! Okay, I'm actually in the middle of getting some work done. Is it okay if I come a little later, or will you be out and about? Oh. Well, right now, Natalia was gonna come over to do some work with me, and I was gonna just drop her off later. Late afternoon. If you're, I mean, I don't want to like force you to come home. Okay, that sounds good. Okay, yeah, maybe. And can you tell me if a debit card is in there? Yeah. Oh yeah, I know. It's because anyway, I forgot if I got it from somebody yesterday because I let them borrow it or use it, and I forget if I got it from them or not. Yeah. Okay, thank you. Okay, thanks. Okay, bye. Sorry about that, guys. All right, so we know that when you have an exponent, again, the big picture here is that something is being squared. Well, when you square something, so something is being squared, that means it's that something times that something. So really, this is going to be all of that craziness times itself. And now we're just so when you're multiplying fractions, you know you can just multiply across and multiply down. So really, I'm going to have 6 times 6. By the way, it's actually easier if you do 6 over 12 as 1/2, and it's 1/2 times 1/2, which is 1/4. But if you don't see that, then you'll do 6 times 6 is 36, divided by 12 times 12, which is 144. But then you're going to have to do all that extra work to realize that that reduces to 1/4. So if you already saw that this is 1/2, and this is 1/2, 1/2 times 1/2 is 1/4. Okay, so I'm going to go ahead and say that's 1/4. Okay, think about why that would be true. Okay, now what happens to the y's? I have y squared and y squared. That's y. So there's y to the 4th. Okay, and then x to the 8th times x to the 8th, that's going to be, there's 8 x's in the end, there's going to be 16 x's. 3 x's down here, so it's going to be 6 x's. 7 y's, 14 y's. So again, if I forget the rule, I could always refer to this. But you know that the shortcut rule, if you have memorized it correctly, is that you can distribute that 2. So 6 squared is 36. And then, anyway, I'm going to reduce that. So y squared times 2, or y squared, but then that squared is y to the 4th, x to the 8th, but then I'm going to distribute that 2, is x to the 16. Distribute that 2 down here, it's going to be 144. So this is going to be 36 over 144. But you realize that if you divide by 36 over 36, then you're going to get 1/4. That's why I ended up putting 1/4 instead of that crazy number. Okay, so 2. Okay, so x cubed squared is x to the 6th, and then x to the 7th squared is x to the y to the 14th. So I'm just showing you that you can use a rule by distributing, or you can just do it the long way. I always think the long way is a safe way if you forget the rules. And then let's see what we can do here. Well, 1/4 is going to stay. The 1 could go invisible. Let's just switch the order. So we have 16 x's here, y to the 4th, okay, x to the 6th, and y to the 14th. Now you might say, well, what do you do with my x's? Now remember, the rule is if you have the same base and you're dividing, then you can actually subtract the bases. Subtract the exponent. 16 minus 6 is 10, and it's a positive 10, so it's going to actually be in the numerator. Okay, y to the 4th over y to the 14th, the same base, dividing, so we can subtract 4 minus 14. 4 minus 14 is negative 10. But since that's a negative, that's going to go in the denominator. If you make it go to the denominator, though, you have to make the exponent positive. Okay, and can I reduce anything here? No, because these are x's, these are y's, they're not related. Even though they have the same exponent, it doesn't really mean anything. You can't simplify that. Now, I really feel like this rule, I don't like to use that rule. I much prefer Ninja Battle because it helps you to understand the why. Let me show you what I mean. Okay, so I'm just going to grab a piece of paper from Jose Luis Santiago's notebook. I hope you don't mind, Jose Luis. Okay, so let's go back here. Let's say I forgot this subtracting rule. If I have 16 x's, and this seems kind of cumbersome, that's 16 x's. I have 4 groups of 4. And then I have 6 x's, right? That's x to the 16th over x to the 6th. What can I do? I could expand everything. This is called expanding when you're multiplying it out. And you know that if you have an x over x, they cancel because x divided by x equals 1. So I have one of these, 2, 3. How many pairs can I cancel at most? There's 60 on top, only 6 on bottom. So I could cancel out all the ones in the bottom. Oops. And so who's going to be left? At the end, who's standing? The top or the bottom? The top had more to begin with, so the top's going to be left. There's nothing going to be left on the bottom, so they all canceled out to make ones. And so, well, there was 16 to begin with. We crossed out 6 of them, so now we're going to have 10 left. And on the bottom, there was nothing left except the 1. And so that's why that whole subtracting rule works. Okay, but if you forget the rule, use this. And the reason the rule is sometimes better is when you might get confused when it's bottom heavy. Okay, that's y over y, and then 10 more. There's 14 of them here, there's 4 of them here, but I know that these 4 can cancel out to become 1, 1, 1, 1. And now who's left? There's only y's on the bottom left. How many are there left? There's going to be 10 of them left. And that's why you can subtract. Now, you don't have to do this if you could remember the rule, but can you remember it accurately? If you don't, you have to just go back to the beginning, which is fine. That's what I always do, because I know I can't go wrong with this. The rule is y to the 4 minus 14, which is y to the negative 10. The only problem is, since it's negative, you can leave it like this, or you can make it 1 over y to the positive 10. But where you can go wrong is if you say, oh, it's negative, I'm going to put it on the bottom, but still keep it negative. No, no, no. If you put it on the bottom, you basically paid for that already. Keep it positive, all right? That was a little long-winded. Again, if these discussions are easy for you and you're rolling your eyes, remember, this is a video, so you can always fast forward. Okay? All right. Number 11. Okay, so now we're kind of building up. We're doing this and kind of one of these all combined. So I want more space, but I want to respect that equal sign business. So here we go. I'm going to first distribute these 3's, okay, the exponent to each product. Okay, so I have 2 cubed times, and I'm going to do this first because remember PEMDAS, parentheses comes first, but nothing in the parentheses simplify. Exponents come next. We cannot start canceling. I can't say 2 over 8 is 1/4, or I can't say 4 over 8 is 1/2, because this is not really a 2 yet. I mean 2. You haven't done what comes first, the exponent. So after that you can start canceling, but you have to do the exponent first before you start canceling, okay? Just like earlier with rational expressions, you have to factor everything first before you start canceling. You got to do your exponents first. So 2 cubed x to the 5th to the 3rd power, we're going to multiply those, not add them, because that's really x to the 5th times x to the 5th times x to the 5th, which means there's 5, 5, 5. There's totally 15 x's. So you're going to multiply. Okay, y to the 9th times 4 squared x squared y to the 8th over this. Okay, now wait. 2 cubed is 8. 4 squared is 16, so 8 times 16. I'm not going to waste time multiplying all of that because I know I'm going to reduce it soon anyway. There's an 8 down there. Okay, there's 15 x's here plus x. There's 2 more x's, not plus, times 2 more x's here. So x to the 15th times x, so that's going to be 17 x's in total. And here it's 9 and 8, so it's 17 y's. Okay, now that everything here is flipped, everything's a product. There's no adding or exponentiating, no powers. Now everything is just multiplied. It's all fully factored. I can start canceling. So 8 over 8 is 1. Okay, the 16 is going to remain. 17x's, 8 to the 17th over 8 to the x to the 17th over x to the 7th. There's going to be, in the end, who's going to win the battle? The top. There's going to be no more x's because he spent them all, canceling out with the tops. And so there's going to be 10 of them left. Here, same thing. The top is winning by 5. Right? And so there's your answer. All right, let's simplify these. Now, again, I back it up, and don't get confused by the inside. Start with the big picture. Something is being cubed, okay? If something is being cubed, then we're going to do it 3 times. You know, there's more than one way to do this, but if you think about it, that's the big picture. Something's being cubed. But, you know, if you could simplify the inside, that might help, because first, we're supposed to do parentheses. So can we simplify what's in the parentheses first? Now let me just do this problem in 2 ways, okay? First way, okay. Oh, I shouldn't call that A because that's not supposed to be confused with that A. Okay, so if I could maintain the big picture, on the big picture level, something is being cubed. But what is being cubed? It's a to the negative third times a to the fifth. Remember, when you have the same base and you're multiplying, you could add the bases. Negative 3 plus 5 is positive 2. Now, if you don't believe me or you have trouble believing me, keep in mind that a to the negative 3 is 1 over a cubed, and then a to the fifth. Well, that's going to be a to the 5 over a cubed, which is going to be a squared. Also because we have a to the 5 minus 3, which is a squared. Okay? So, there it is, a squared. What does a squared to the cube power mean? Well, we can multiply those exponents because it's just a squared to the third power, and we can multiply those exponents, which is going to be a to the 6th. Again, if you have a hard time believing me, expand it out. A squared, it's something being cubed, right? Well, it's AA, in the end you have 6 a's, right? Another way you could have done it is distribute that 3, okay? So here's method B. That's going to be a to the negative third cubed times a to the fifth cubed. Well, when you multiply those out, you get a to the negative 9 times a to the 15th. We have the same base here, so we can just do negative 9 plus 15, which is a to the 6th. Okay? Alright, now this one, some of you guys have a different order on your test. It's okay. Just find the one that looks like this. When you have the same base, remember you can add the exponent. So negative 3 plus 3. Okay, so it's something plus something. That's the big picture. Something plus something. These are 2 multiples with the same base. So I can add those. Well, negative 3 plus 3 is 0. So should the whole thing become 0? No, it's just the exponent that was 0. 4 minus 4 is 0. But remember, anything, whether it's an x or a y, anything to the 0 power is 1. Y to the 0 power is 1. And we're adding them, so we have 2. Okay? Another way, if you don't like this, if this line confuses you, consider this. Consider this. If x to the negative 3 means 1 over x cubed, x to the positive 3 means x cubed. Well, what's x cubed divided by x cubed? 1. Right? And then y to the 4th times y to the negative 4th is 1 over y to the 4th. And that is also 1, which again, when you add them, is 2. Right? Number 14. Okay, now this is going back to rational expressions, which we covered in tutoring the other day. You can only cancel. Can I start canceling out? Whoa, 3, shoo, 8. No, that's a red flag. You can only cancel out once you've fully factored a fraction. These are not products. These are not multiplying. These are adding. So you cannot cancel stuff out. If they're being added, they have to be being multiplied. You can only cancel stuff out. And if you have a hard time believing me, consider this. What is going on? Okay, consider this. If I have this, can I cancel the 3's? Yes, because it's factored and these are being multiplied. These are products. So that's 2 over 10, which I could again factor out 2 times 5. Okay, so that's 1/5. That is good. But if it was 3 plus 2 over 3 plus 10, can I factor this out like this? No! Red flag. We cannot do that. Okay? Because what is this really? These are being added, not multiplied. And you cannot just do that because this is really 5 over 13, which clearly is not 2 over 10. Okay? So same thing goes here. We have to factor first. Well, let's see. Can I factor out the top? No, I can't. Can I factor the bottom? Oh, and you know what else I want to do? I want to put parentheses. Okay. Can I factor out the bottom? Yes, we can. Well, let's see. The X method is used for factoring. Okay? The X method is for factoring. 3 times 3 is 9. The middle coefficient is 10. What two numbers multiply to 9 but add up to 10? 3 times 3 does not add up to 10. But 9 times 1 does add up to 10. So at this point, I like to use the grouping, factoring by grouping. Or in other words, it's called the split the middle method. 3x squared. What is 10x? 10x is 9x plus 1x. Isn't that true? Isn't it? That 10x is 9x plus 1x? But now I could group these together and group those and factor them separately. If I could factor out a 3 and an x here, I'm going to be left with an x plus 3. If I don't have to be able to factor out anything except that 1, then x plus 3. And look, we have x plus 3 in that term and that term. I'm going to factor out that x plus 3, and what am I left with? 3x and a 1. Okay, so there it is. Okay, so all of that is x plus 3 times 3x plus 1. Now, if that factoring by grouping did not jibe well with you, you always have the dependable box method. The box method is for factoring when the coefficient a does not equal 1. Like right now, the coefficient does not equal 1. So now, it's really the same thing. What do we have here? We have 3x squared plus 3 plus 10x, but I'm going to split, just like we did here, we're going to split that 10x into the 9x and the 1x. So we're going to split it, okay, into 9x and 1x. And just like we did before, we're going to, now that we have it kind of divided up, we're going to factor out. What can I factor out of here? An x. Okay, the area of this, so if these both have an x, I can factor it out. This is really an area model. If this rectangle is 3x squared, but this side is x, what does this side have to be? 3x. That way when you multiply them, 3x times x is 3x squared. If this area is 1x, and you factor it out of x, there's nothing here except the 1. Alright, well look, this is 3x according to what we said earlier, but this whole box is 9x, so then what do we factor out? What's left is 3. That way we do 3x times 3, we get 9x. And if we did it correctly, it should match. 1 times 3 is 3. So now we have 3x plus 1 and x plus 3, which is what we got doing the grouping method. So this and this is the same thing. Okay? Now that we fully factored, now we have everything as a being multiplied, everything is a product, not a sum. So now we have it like this and not like this. We can start canceling out. Well look, 3x plus 1 and 3x plus 1. So we're left with 1 over x plus 3. And I would feel so much better if you kept it like that. Here's the thing though, some of you guys if you said 1 over x plus 3, that is wrong. Because you know what that equals? That, according to PEMDAS, is divide first and then add. And that's not what you're trying to say, right? So make sure you use horizontal fraction bars, not the slash business. And if you really don't have space, then you can say 1 over parentheses x plus 3. But without the parentheses, it would be wrong. Okay? All right. Now we're going to go down to number 15, which again is a different order for some of you guys. Hey, let's do this one while we're at it. Anything to the 0 power is 1. Freebie. Okay. Just like before, we're going to have to factor. Now you have to know this rule. This is the difference of squares. The difference of square rules. Squares rule is that if you have a squared minus b squared, anything minus squared minus something else squared factors to a plus b times a minus b. And this, my friends, is a difference of squared because x squared is x squared and 64 is 8 squared. So it's really x squared minus 8 squared, which is x plus 8 times x minus 8. All over. How can I factor that out? This one you should also recognize. This is a rule. This is the square of a sum rule. You should know that if you have a plus b, the whole thing squared, once you expand and multiply and factor that out, distribute, you should get a squared plus 2ab plus b squared. So if you ever have to factor something where the first number is a square and the last number is a square, check to see if the middle is just the first number times the second number times 2. Because if it is, then you can right away recognize that it factors to this plus this, the whole thing squared. Notice here, x squared is a square. 64 is also a square. It's 8 squared. And look, the middle, 16x, is really 8 times x doubled. So it fits this rule. So right away you can tell that this is x plus 8 squared. But if you didn't see that, we would have to use the x method. So 1 times 64 is 64. 16 is here. What two numbers multiply to 64 but add to 16? 8. So you know you have x plus 8 times x plus 8, which is x plus 8 squared. If you have x plus 8 squared, but you have one x plus 8 there, you know that one of the x plus 8s can cancel, so you're left with x minus 8 times x plus 8. Okay? The only way you can use a slashed, that would be wrong, because that means x minus 8 over x plus 8. That would be basically saying x minus 8 over x plus 8. Is that what you want? No. So if you're going to try to use a slash, you have to have the parentheses, especially, for example, on your calculator. That's why I really avoid using these. I always like to keep it this way. Keep it real, okay? All right. Now, this is for version B only. Okay, version A people, I will have your problems in a second. But you guys should still pay attention to these because these will help you understand better. Okay, there's multiple ways to do this problem. Okay, I'll do it in 2 ways again. Let's try version A. Okay, one thing I would do, first of all, is take care of the exponent. And the exponent is a negative exponent. Whatever this is, don't be scared by the fact that it's a fraction. Something is being exponentiated. But the exponent is a fraction and it's a negative, so it's 2 confusing things at once. So let's first take care of the fraction. The fractional exponent makes it go to the denominator, and now that exponent is now positive and it's a 1/3. Now let's think about what does a fractional exponent make you do. The fractional 1 over 3, that is a cubed root. So I'm going to go for the cubed root of 1 over 27. Well, the thing is, what number multiplied by 3 times gives you 1 over 27. You know that it's 1/3. Because 1/3 times 1/3 times 1/3 gives you 1 over 27. If you didn't like that, you could have said, hey, that's 1 times 1/3 over 27 to the 1/3, not times, to the 1/3, which equals 1 over 1, the cubed root of 1 over the cubed root of 27. Cubed root of 1 is 1, because 1 times 1 times 1 is 1. And cubed root of 27 is 3, because 3 times 3 times 3 is 27. Okay? Now, if you have 1 over a fraction, you're going to copy, change that division sign into a multiplication sign, copy, change, and then flip. So 1 times 3 over 1 is just 3. You know that 1 over anything, that means to get the reciprocal of that anything. So 1 over blank is reciprocal. Okay? So reciprocal of 1/3 is 3 over 1. All right. Okay, now another way you can do it is, you know that negative, and you know how we said that makes it go to the denominator? But going to the denominator is the same thing as doing the reciprocal. So really, instead of making it go to the denominator, we could actually just reciprocate that one, or do the reciprocal of 1 over 27, which is 27 over 1. And that will take care of that negative exponent just as well. And so it's just 27 to the 1/3, which is the cubed root of 27, which is 3. Okay. All right, number 16, we can do that again. First, take care of the negative exponent. That makes it 1 over 16 to the positive 3/4. All right, well, what is the 3? You know that the 3/4 means, okay, it means two things. 16 to the 3/4, you can make that to be 16 cubed to the 1/4, or you can make it 16 to the 1/4 cubed. Do you see how 3 times 1/4 is the same thing as 1/4 times 3? Okay, and so remember, the 1/4 power means a 4th root, so it's the 4th root of 16 cubed. Or we can say first it's 16 cubed root of 16, all of that to the 3rd power. Now, which looks easier? To do 16 times 16 times 16 and take the 4th root of that humongous number, or to do the 4th root of 16 and then to cube that number? I think this one is easier. Also, because we should know that the 4th root of 16, what number do you have to multiply by itself? 1, 2, 3, 4 times to get 16. 2, right? 2 times 2 times 2 times 2 is 16. So the 4th root of 16 is 2. And then we cube 2 to get 8. Okay? So I'm going to say this is 16 to the 4th root, all of that cubed. And the 4th root of 16 is 2, and 2 cubed is 8. So my answer is 1 over 8. All right, number 19. A lot of people got this halfway right, but didn't go all the way. X to the 3/2, again, you can do it in two ways. It's x cubed to the 1/2, or you can say it's x to the 1/2 cubed. Either way, x cubed, if you do 1/2 power, 1/2 is a square root of x cubed. Okay, but you left it like that. But what's the square root of x cubed? X cubed is x times x times x. And guess what? There's a pair of x's here. There's an x squared there. That could come out of the house. So then I have x on the outside. One of those x's stayed, and so I have x rad x. If I had done it the other way, this is the square root of x, which means it's rad x times rad x times rad x. About that x, about that x. But what's x rad x times rad x? The square root of x squared is just x. And then I have my rad x. Okay? And then number 20, I'm going to deal with the outside first. That negative exponent makes this whole base go to the denominator, so 9x cubed y to the 6th, all of that to the positive 2 power, which means I'm going to distribute that exponent, so it's 9 squared x to the 6th, y to the 12th. 9 squared is 81. Oops. And there's nothing else I can do, so you can leave that as 1 over 81 times x to the 6th, 9 to the 12th. Now, if you, and so here are the answers, you can, if you'd like, have left this as 1 over 81 times x to the negative 6 times y to the negative 12. Okay? Likewise, you could have left this as 1/4 times x to the 10th times y to the negative 10. Same thing. Okay, after watching this video, if you still have questions, feel free to message me with specific questions or even a copy of your work and where you're stuck, and I'd be happy to help. All right, next.